Hey guys, welcome to Science Today, Tuesday, April 28th. And I'm going to go fairly quickly today. We're going to do some notes together. The notes are right here, and you can look at them in PDF form, but I want you to write them down because you'll learn better writing stuff down. Everybody does. So you're going to need some type of a journal or a key tab or just a section in your binder. And we're going to do several sets of notes in this term 3 earth science stuff. So you need that. So you're already clicked on this video here. It's going to look different once I get it all together. This view is different than your view, but it's not finished yet. That's why it looks different. So today I'm actually going to start the video and we're going to work through some things together. It's also got a short little video inside it, which is it's not very exciting. The narrator is definitely not a very exciting to listen to, but it's got good content. So I moved myself right into the line of vision here. So I'll move down here again. So the title today is To Drift or Not to Drift. And if I'm moving too fast, that's okay, because you can pause the video at any point, or you can rewind it, or you can just get the PDF copy. So here's what we know today. Let me start scrolling our way through, if it will let me. There we go. Continental drift and plate tectonics are two theories that scientists believe explain many of our geologic features. And our geologic features are things like mountains, volcanoes, ocean rifts, seafloor spreading. And I won't get really deep into the background or the history of continental drift and plate tectonics, but they're essentially this. If you look at our continents on our globe today, they look like they fit together like a puzzle. And the theory is, and this is all theoretical because nobody was here 4.3 billion years ago, and or 10,000 years ago, or who knows? None of us were here to record this. So continental drift is just the theory that continents are actually moving around, and it's very slow, between 1 and 10 centimeters a year. And we are, like, the continents do move. The GPS systems will tell us that there is some movement that's happening. And plate tectonics is just the shifting of these plates. Now, plate's a funny word because you think dinner plates, but this is more like the crust of Earth. And we did the layers of Earth. And if you think of the layers of Earth, you have to think about like a peach. And the pit of the peach would be like the inner and outer core. All the fruit would be like the mantle. And then just the very outside skin would be like the crust. It's very thin. And then like the peach fuzz would be like the atmosphere. And that's a pretty good representation of our planet. But the crust, the very thin outer crust, is broken into pieces, and they call them plates. They could have just said pieces, but they're called plates. And they are moving around. We're going to talk about a few examples today. So basically, the theory states that Earth's crust is divided up into many different sections called plates. So that's just what I said. So if you look at this map, it's kind of tough to see, but here we are over here in BC. So this is North America right here. Here's South America right here, right? This is Africa, the continent, and Asia over here, right? This is all ocean. I know it looks, the colors, you have to kind of let your eyes adjust to the color. And then Europe is over here, Australia is here. So these colors are not continents, they're plates. These are where cracks are in our surface, right? So you can see that there's a gigantic plate that North America sits on top of, right? And then there's these little Juan de Fuca plate and the Pacific plate and the North American plate, and they all interact right here. And of course, these are 50 kilometers thick and thousands of kilometers of square, or thousands of square kilometers. So when they interact, earthquakes happen. Like things move, you feel it. Okay. All right. So these plates actually drift or slide along on top of the mantle. And those are strong words because it sounds like they're moving like ice across a pond. Remember, this is really slow, like 10 centimeters a year that's the fastest of the moving plates. Some scientists believe that all 7 continents used to be one supercontinent called Pangaea. And that's obviously a name that we superimposed on that because there was no people around to give it that name at the time. But they think that all the continents, based on the way they're moving now, once were all lined up together. Again, I want to reiterate that this is all theoretical and it's neat to talk about, and there's evidence to support it too, but it's all theoretical at this point. Okay. So some of the evidence to support this theory includes coastlines separated by vast oceans fit well together. And we'll look at that in just a minute. And the mineral and fossil records at meeting coastlines are also very similar. So it's pretty compelling. And if I were to look at this map of maybe what it would have looked like, Pangea, this shape, all the continents together, way back 225 million years ago. Again, there's a huge range of numbers depending on who you're talking to. And then the Triassic period, Jurassic, what's famous for dinosaurs, right? You can see them separating apart, and they are moving apart today, which is where this theory comes from. Okay, and here, this is interesting, because if you were to look at our world, look at how nicely Africa right here fits right into here, right? This puzzle fit, okay? And Australia just fits nicely right up into there. And if you, and not perfect, of course, because if it was moving apart, then some would break off and some would be under the ocean. You wouldn't see some of the parts, right? But it fits very well together. And what else is really interesting is the fossil records, the records of things once living, on these coastlines separating by this huge ocean, are very similar. Okay, the mineral record, the fossil record, even though they're all the way across the Atlantic Ocean, they're very, very similar. So some compelling evidence for sure. So we're going to watch a video now, and do your best to stay awake. The narrator is pretty funny. He does weird pauses and stuff. But watch the video, and then we have a few more points, and then we'll be done. They'll be done. Then we will be done.
To understand more about plate tectonics and continental drift, we have to look deep inside the Earth. The Earth's interior consists of several different layers. The inner core, which is believed to be solid iron and which is very hot. The outer core, which is believed to consist of rocky material so hot and under such great pressure that it is in a liquid state. The mantle, which is not as hot as the outer core and not as liquid. The mantle's outermost portion is solid. This is the solid outer portion of the mantle. Above this is the outermost layer of the Earth, the crust. Together, the crust and solid outer portion of the mantle form the Earth's outer shell. They are referred to as the lithosphere. It's not always easy to see the Earth's crust. It's covered by vegetation and the oceans. But if you could drain the Earth's oceans and strip away our planet's vegetation, the Earth might look something like this. Now we can see the Earth's hard outer shell. And if you look closely, you can also see the shell is cracked. The red glowing lines mark the places where the Earth's shell is cracked into tectonic plates. Each plate carries a continent or an ocean basin, or sometimes both. The plates are moving at an average rate of 1 to 2 inches a year in a variety of directions, carrying continents and ocean basins with them. Here's why the plates are moving. Scientists believe material in the mantle is circulating much as it is doing here. The movement may be caused by heat within the mantle. You can get an idea of how heat can cause a circulating movement by watching rice as it boils. What you see happening within this beaker is similar to what's happening within the Earth's mantle. As mantle material moves, perhaps only inches a year, it causes the plates above it to move as well. In some places, plates are moving in opposite directions. They are moving apart. The area where two plates are moving apart is called a divergent boundary. In other places, plates are colliding. The area where two plates are colliding is called a convergent boundary. And in other places, plates slide past each other. This area is called a transform boundary. This is a cross-section of a divergent boundary, the mid-ocean ridge, located beneath the Atlantic Ocean. The North American plate is on the left, and the Eurasian plate is on the right. Scientists believe that as the plates move apart, mantle material called magma rises to fill the gap. Magma is the name we give lava before it erupts from volcanoes, as it is doing here. The magma cools and hardens on the ocean floor, adding new crust to old. And as the seafloor spreads, North America moves farther away from Asia. The highlighted area on this globe shows where magma is surfacing between plate boundaries beneath the oceans, creating a mid-ocean ridge that circles the Earth. The ocean floor spreads in one direction on one side of the ridge, and in the opposite direction on the other. The mid-ocean ridge is where plate material is created. And this is where plate material is destroyed, a convergent boundary. In this cross-section, the plate on the right is carrying an ocean basin and is moving in this direction. The plate on the left is carrying a continent and is moving in the opposite direction. The plate carrying the ocean basin is heavier and is diving beneath the plate carrying the continent. The leading edge of the diving plate is consumed back into the Earth's mantle. When one plate dives beneath another, it is called subduction, and the area where it occurs is called a subduction zone. Subduction may resemble what is happening on this lava lake, as sections of hardened crust dive beneath other sections. The highlighted areas on this globe mark convergent boundaries. Subduction is occurring at most of them. These are the areas where plate material is destroyed. Here again are divergent boundaries, where plate material is being created. Again, most of them are beneath the oceans, creating a mid-ocean ridge that circles the globe.
Okay, so I know it was not the most exciting video, but there's some really good information in there about the boundaries, the places where plates are meeting, and we'll talk way more about this. This is just an introduction today. So I want to just finish with a few thoughts. So things that scientists know. So much of science is theory, and lots of it's good theory. Some of it is, some of it's not, and that's always been the way it goes. History seems to keep the positive thing, or the things that are provable or are good theories, and then the ones that aren't, they disappear. Right? The Earth is not flat, and we don't revolve, or the planets don't revolve around us. And So anyway, we do know that we're in motion. Some of the plates are spreading apart as much as 10 centimeters a year. Most of the movement, not even much. Most of the movement is much, much slower than that, like 1 centimeter. So very slow. These plates spread apart, they collide together, or they scrape along past each side of each other. So you've got two plates when they come together, and there's no space between the plates. I think that's something that's a misconception too. It's like a hard-boiled egg. If you broke the shell of it but didn't peel any parts off, that would be like the crust of Earth, right? There's no space between them. So when plates are moving towards each other, something has to happen, and that's usually subduction. One gets pushed onto the other, right? Or mountain building, they get pushed up. When they pull apart, right, there's lava and pressure down below, right? So it comes up, and you have new material being created. And when they slide past each other, there's this total friction, grinding, sliding motion that happens, and that's where you get earthquakes and lots of destruction. So those are the different zones, and we'll get more into that. The interaction of these plates causes rifts in, I'm going to move this up so you can see it, rifts in the seafloor, mountains to build on continents, and volcanoes. All right, back here. Volcanoes and earthquakes, right? That's the transform, the ones that slide past each other. Okay, so I'm going to stop here for today. We don't even need to write these down, but we're going to talk about the plate interactions next time. Thank you for sticking with me. If you want to watch this again, then please feel free to do so. You can write the notes beforehand, or you can just wait. We'll go through the rest of the notes next week. Take care, everybody.